So people were having a little bit of trouble in the lab today working through Lab 3, and I'm not sure if that's because they hadn't reviewed the reading yet or taken out the study guide. Just a reminder that I have PowerPoint note slides that go along with the video lecture and the lectures that I use in class, and there is a reading with content each week that goes along with what I'm covering in the class. You do need to have a copy of the Eugene East topographic map. There are copies for everybody. I handed out in class, and those of you online, you can download this. You can order it from the USGS, probably a little late for this week, and there are copies for you in the social science office. So the first thing you need to do is to make a ruler using the graphic scale here at the bottom of the map. I'm going to zoom into that a little bit. And if you line your paper up with the end of this scale, you could make a ruler that is 1 mile, 2 miles long. Move your paper down 3, 4 miles long, and you can get a pretty nice length of ruler on an 8.5 by 11 sheet of paper. And then remember, the distance between two location points can be measured in miles or feet, but I wanted you to tell me if you had to walk from 44 degrees north latitude to 44 degrees 7 minutes 30 seconds north latitude, how many miles would that be? And a couple people used the 69 mile per degree and figured it out, but that won't work for longitude. For longitude, you'd have to use a trig function, and I was really wanting you just to actually physically measure the difference between the two, latitude and longitude. The second task then is to measure the distance as the crow flies from the center of campus to Autzen. And so here is the center building on campus. If you haven't watched the videos, I do talk about that. And then Autzen is pretty definitive here. So, and as the crow flies is an idiom that just means in a straight line, not taking any account for hills or different roads. And then you're going to measure the same distance using Google Earth and then discuss kind of what impacts accuracy there. The second task I'm going to ask you to do is to validate or to determine the scale using a map, a topographic map, where you know what the representative fraction scale is, and a map where you don't know what the scale is. And so I have given you a copy of, let's see, where did it go? A copy of a map that has no scale on it. And I want you to look at the map. Is the feature larger or smaller? So if they're larger, what would the scale? Would it increase or decrease? If they're smaller, would the scale decrease or increase? And then determine the scale, setting up a ratio relationship. So the first thing you want to do is measure a distance on one of the maps and then measure that same distance on the other map. So on this map with no scale, you could measure from here to here pretty clearly. Then you could pull that up in the topographic map and measure, yeah, I did on the other side of that. So you could measure from here to here. So this would be the length of the feature on the topographic map or the known map, and this would be the length of the feature on the map with the unknown scale. Where's my Excel? Oh, rats, I closed that sucker. Okay, so then you're going to set up your ratio. Remember, a representative fraction, you want 1 to some number when you're done. 1 to some number, and I don't know what that number is, right? Okay. So that's what you want to end up with. So you're going to take the length of the feature on the topo map, on topo, and I call that the known. And you're going to divide it by itself. When you divide something by itself, you get 1. All right, so that's this side of the equation. Then you're going to take that length again and multiply it by the known scale. And in this example, the scale was, I said known scale. The scale was 24,000. And then you're going to take that and divide it by the length of the feature on the unknown, on the map with an unknown scale. And this is going to give you this relationship. Now, you can do this in millimeters, you can do it in centimeters, you can do it in inches, you can do it in decimal inches. And because you're using the same units to measure all 4 of these, or both of these lengths, you can drop off the units, which is what a representative fraction is. So that's determining that scale. I also ask students, or ask you in this lab, to convert a word scale to an RF. So remember, that's what you want to end up with. So if I give you 4 inches equals, equals 100 miles, you can do the conversion here, but it's a lot easier just to divide both of these by 4. So then I'm going to end up with 1 inch equals 25 miles. Oh, it doesn't like when I do. I have to put a space here. Hold on. Now, often a student will stop right here and then turn this into a representative fraction, but that's not correct because you have not completed the math here. I need to make this one. In order to take off the units, I have to make the units the same on both sides, and I haven't done that here. So I've got to convert that. Ooh, wait, is there like a cross-out thing? No, I don't know where the cross-out thing is. Okay, why am I wasting time with the cross-out thing? Wait, it is here. Oh, now I'm going to crash the computer. Dang it. There we go. Okay, so that doesn't work. All right, so I've got to go here 1 inch, and now I have to convert this 25 miles into inches. So I know that there are 12 inches in 1 foot. And I know that there are 5,280 feet in a mile, and I know that I have 25 miles. So now I have 1 inch equals inches, and now I can take off the units. So I can come up with a ratio fraction that is 1,58400. Because those units are the same at the end, I can do that. Okay? Now, if I give you a representative fraction or a ratio fraction of 1 to 600. Okay? Well, that was pretty cute. I'm going to have to do it this way. 1 to 600. Okay? So what I'm saying is 1 inch equals 600 inches. You know what? I'm going to do 6,000 because that'll be a silly number when I'm done. Might still be a silly number, but anyway. Okay, so 1 inch equals... Stop it. Nope. Come on. Space. Man. 6,000 inches. Okay, so I've got 1 inch equals 6,000 inches. So now I'm going to leave the 1 inch, and I want to say 1 inch equals some amount of feet, because that would make a little more sense for somebody using my map. So I'm going to take the 6,000 inches and divide that by 5,280. Well, that was still a dumb number. No, that's miles. Sorry, I goofed that one up. So I'm going to do 6,000, and I'm going to divide that by 12 times 5,280. There we go, because I want to get back to miles, because that's 10. So 1 inch is about 0.9 miles is how I would write that out. Okay, so that's converting it the other way. Let's see, where are we? So that's the topographic length, that's the units. You're going to do a very similar thing, determining what the scale is of a Google Earth image when you're zoomed into a certain, when the stadium is 6 inches. And then this is directly the example used in the lecture, and you're going to recalculate that using New Hampshire. Remember, to get this right, you have to tell me which of these scales. I need to see both scales calculated, and then I need to see which scale you would actually use.